All right,
Ready to go?
there you go.
All right, thank you. Okay, so the last few sessions we've had here, the last couple of days, we've talked about the HVAC basics, and we've talked about some of the gas products that are made in this facility. Today, we're going to touch upon one of the things that Doug's company, or LJ Wing, does. So, the gas heating systems, we talked about direct gas-fired units, where the burner is directly in the airstream. So, very efficient. But the one drawback is you have products of combustion in the airstream, so there's limitations because of that, when and where you can use it. Then we've got the indirect gas-fired heaters, where we fire into the chamber. The chamber heats up. That's how we heat the air. Then it's with that hot air going over the chamber. Products of combustion are then vented outdoors, so it's a very safe product, and a lot more things we can do with it. 100% return air, various applications that we can do with these that might not work for direct fired. So between those two, we use them for a lot of our heating systems. But then we also get into, not at Dallas per se, but in the heating business, gas-fired boilers, where now we heat up water, we're going to use to heat the space or make up air, whatever it might be. So we're going to talk about that today. So a gas-fired boiler, I'm calling it gas-fired because we just take one gas-fired product. They can be oil, they can be electric, and you get the very low industrial plants. They can be cold. So we're just talking about gas-fired components in general. That's why I'm saying that. So now, rather than pumping hot air throughout ductwork through a complete campus, whatever it might be, we're going to be able to heat up that water and pump that through the spaces versus ductwork. So if the ductwork this big or piping this big, which is going to work out better for large applications. So a hot water boiler, maintaining temperatures below steam point. Typically the water that we see going through the coils of products that we build are going to be between 180 200 degrees. They see some variance there, but that's a good range where you might see the water that we're introducing to the coil. So that's a hot water coil. If you get into steam, there's various things for pressures you have to work with. A low pressure boiler has a working pressure up to 15 pounds. You get above that, over 15 pounds, those are medium or high pressure, and those get pretty special. Get up to a certain point, you have to have a licensed operator on site at all times to operate, where low pressure boilers aren't quite as critical. But what does that give us between the two? If you remember some of our earlier sessions, and we talked about what are the BTU? By definition, 1 BTU heats a pound of water 1 degree. Well, so think about it now, between 32 degrees right at the verge of making ice and 212 right at the verge of making steam, that's 180 BTU to get that point, because you're raising from 32 to 212 and 180 degrees, 180 BTU in theory. Now, what if you wanted to make that 32 degree water into ice? To go from water to ice, we're changing state now, the latent heat we've been talking about. It takes 144 BTU to go from water to ice because we're changing state. So almost as many BTU there as the difference between steam and ice. Or yeah. Now let's go to the top extreme. Let's go up to 212. At 212 degrees, it's still water. Until you make steam, you have to add 970 BTU to it to get from 212 water to 212 steam. That's the latent heat required to change the state. So you can see that big jump in BTU. You have to put that into it to make the steam. But once that steam goes through your system, you can recover that many BTU. So you can see the big difference of how much more heat steam can give us versus hot water. 970 BTU at that particular point to get water to steam because you're changing state. That's the latent heat talking about the last couple days. So as that water heats up, it gives us water or steam. That's now circulated through the space, the various heat exchangers, whatever it might be. And so those systems now are gonna have a loop that we have to go through, and it goes around there. And there's a number of additional components that have to be added. We don't add them. These are just specialties that piping contractor have to add, but they're important to know why they have to be there. And Mr. Doug's gonna help us on this. We're gonna tag team on this. Want to talk about some of the things that we have to put in the system and why.
Okay. What we have up here right now is one of our VIFB coils. To pipe up a water coil, you need an automatic air vent, shut off valve where you can isolate it, and you need a flex connector. Because as steam or as hot water heats up these fin tubes, they grow in length a little bit. So we need to take that up with a flex connector. And other than that, you need to be able to drain it down and isolate it while you drain it down. Now that at 0 gauge pressure, 212 degrees, that's where you start beginning to make steam. A point I kind of wanted to make, every one of you have probably seen or have a tea kettle that you use at your house. And so as you put that on the fire or on the burner to heat that water up, and it starts heating up and the water starts bubbling because it's expanding and releasing the air out of the water, eventually it's going to get to the point where it's turning to, boiling and starting to turn to steam. And with the little flapper deal on the nozzle of it, that steam just kind of lazily starts coming out of the nozzle. But if you flip that little nozzle back down, you're actually putting a little bit of pressure on that steam kettle, and that's what makes it whistle to let you know, hey, we're up to steam temperature. So that's an orifice. So you actually put a slight pressure to it. So 15 psi steam is 250 degrees. That's a very common steam pressure that we use in commercial and industrial buildings. Sometimes it'll go higher than that, but we start at 212. 15 psi is the beginning point of medium pressure steam. We see steam pressures all the time in between here, but that's a common one to look at. So I kind of wanted to make a point, and I'll use this throughout the presentation, that 15 psi steam is 250 degrees, which is quite hot. Now that a little, instead of the steam kettle, now we have a boiler. It's a true pressure vessel. And this slide shows 100 psi, but just works the exact same for 15 psi. The fire heats up the water bubbles and turns into steam, runs through the piping. Now keep in mind, unlike a water system, hydronics hot water system, you have to pump that water through there. It's a fluid. So, but when it turns to steam, you don't need a pump. It flies through those pipes. And you can have the pressure reducing valve and drop it down to a different steam pressure, like 5 psi, going into a fan coil unit or a unit heater. So as that steam goes through that unit heater and through that coil, and we're blowing cold air across that coil, that steam begins to change states again from a vapor back to a fluid. We call that condensate. So the whole purpose of all these traps, did somebody have a question? The purpose of all of these traps on each one of these devices is to trap the steam and keep it out of the condensate piping and allow water to flow. So and as that changes states within that coil, it can actually go from say 15 PSI, steam all the way into a negative. And we want to break that vacuum as we go through there. The yellow you see here, that condensate's still very, very hot. So start out with 50 degree, 15-pound steam. It drops in temperature a little bit, but it's still pretty hot and above 212. So as it gets in these pipes headed to this condensate receiver, you can flash back into steam. So there's a vent up here, and you've seen manholes in New York City where there's steam coming up through there. They're venting off that excess steam, off of that pieces of equipment. And a lot of times in industrial plants, you'll see a plume of steam coming off of a building. They run that vent up to a roof to get it so it's safe to vent that steam. But that's just a basic configuration of different pieces of equipment, how a steam and condensate circuit works. Any questions?
Is the water have to be treated?
Yeah, typically they do because
Mineral.
they'll have a water treatment system in between here and that boiler.
Okay.
And on the makeup
And
water.
the boiling point is gonna be different, depends on the elevation.
Yeah.
Your city is to the,
Yeah, and if you have to treat steam because it can develop into an acid called carbolic acid, and that's part of what they treat for.
But you are correct. All these temperatures are based on a sea level conditions.
Right.
Yeah,
Standard air.
Right.
Okay.
The boiling temperature changes as you're climbing altitude. So ask questions. That's what we're here for. This is a typical piping configuration for a wing coil. Now, we don't furnish any of this stuff except for that flex connector, but this is typically how you should pipe one up. Got the steam entering back over here, and there's a little trap. Every 100 feet of steam piping, you have to have what's called a drip trap, because that's, even though that's steam lines, that insulated line, it'll cool a little bit. You get condensate or water in the bottom of the pipe, and you want to drain that off. Otherwise, it makes waves and can be a problem. So at the end of every run going to a piece of equipment should be that little trap to drain off that excess water. It's going to come through this coil. We're going to blow cold air across it to get whatever temperature downstream that we want. And like I said, it can turn into a negative inside this coil, depending on what those entering and leaving air temperatures are. So we want a vacuum breaker before we hit that trap, so that we can break that vacuum that can set up there and keep that water flowing. We don't want hot water that's hot water is expanded, so therefore the air molecules in it are what's still in there is very large, and that water, if it hangs up or is held due to a vacuum in that coil, can freeze in just seconds. So we want to keep that moving, get it out of the coil. So that's very important. There's one up here that's a vacuum breaker also, but somewhere at the high point of this system needs to be an air vent, so that as air comes through this system, we want to expel that. Air compresses, and we don't need that extra pressure in there bouncing that steam around. These are the flex connector. This is a bottom float on a vertical coil. The bottom header is a floating header. So the top one's stationary, bolted in. The bottom one is floating because fin tubes, being made out of copper, and you hit it with 250 degree steam, will grow in length. So that flex connector is very important. It takes up that growth or length of those tubes while they're hot. So the trap, we're showing an inverted bucket trap. We also, on other steam systems, use what's called a F&T trap. I'm not going to get in how traps work, Be glad to have you that, give you that as a separate class someday. But typically you have a trap, and that is to separate steam and condensate, so that just the water can be drained off.
The functional trap is not like two line.
No, it's kind of like it's a combination of a check valve and a vent, and does about 3 or 4 different functions. But it's mainly to drain the water off and keep steam. Let me go back to that. Keep steam that can come, depending on the temperature and the heat transfer through the coil. Steam can come all the way up to this point, to the trap. And we don't want steam going into the water system. We'll stop it there. So that all we should get is water coming down to the
How
condensation.
big is those traps? I
Mm,
mean, you can tell by this schematic.
That trap will be, really, they're cast iron traps, and typically on a bucket trap is about that big.
Pressurized, I mean, that's,
So it's not real, it's not huge.
okay.
You could, a pump trap, which is a different kind, actually has like a receiver built into it, and it pumps the condensate out of it. They get quite large. So they're, depending on the pressure and the temperature and how much condensate is going to be coming off of that coil, and that we calculate all that, that'll tell you how big a trap.
Are these the same system they use in Europe for like a radiators in every room to heat and cool?
Yeah, that same flow that we
Yeah.
were showing could be a branch going off to heat radiators or fin tube, baseboard fin tube.
I noticed they have it on the floor too, at the bottom of the floor, so when you get up.
Yeah, in-floor heating, and the same way with the snow melt system. They melt snow off driveways with the radiant floorings and turn them out. Thinking of it. So hydronic systems, you can take this one.
Well, you already covered most of them. Just go ahead and hit them. You used to the subject expert.
How can we now heat the space with either hot water or steam? Right, here's your radiator. So
We talked about radiators.
we can, the old cast iron radiators that you see in some buildings, they run either hot water or steam through them. And they had a little temperature valve that adjusted the flow through there to give you your temperature. Baseboard, kind of the same way. Mess Tech with a K kind of owns the baseboard radiant market. They bought up just about every company out there that builds baseboard. And I actually worked for a company at one time, and they bought the baseboard. Mess Tech bought the baseboard part of it. Radiant floor is the in-floor tubes that you were talking about. They circulate tubes at normally a lower, that's hot water, normally at a lower temperature, to keep everything from the floor. So you can if you get on the floor and play with kids, the floor is warm, all the way to towel racks. So your towels are warm when you get out of the shower. There's all kinds of hot water radiant accessories that if you can get. There's nothing better than step out of the shower onto a warm floor. It's pretty nice. I've been in a hotel where they had that.
That was in Italy.
Yeah.
Everywhere we go, they had a warm
Yeah.
floor.
And the towel, you go to grab that towel and you got a towel rack that's heated with hot water. It's nice to dry off with a hot towel. So in our business, we use air handling units. And we run a coil through a big air handling units that's moving a lot of CFM. And Mez Techs builds some of those kinds of pieces of equipment. We also sell coils to OEM customers that build much bigger pieces of equipment.
I got a question. These calls we get in, are they charged or this is, we charge them?
Charge.
DX calls we getting, are they charged from it?
Yes,
No, they're charged with nitrogen.
yeah, charged with nitrogen. No,
Oh, we don't do it. I mean,
No,
they charge it
we-
before it's sent.
we have them. We have them come in charged. They have a Schrader valve so that we check the
So we do
pressure.
that here.
Yeah.
Okay.
Get the next one. I didn't mean to do your part.
So now that you see some of those options, and we're gonna talk about the air handler side, what Wing offers are coils. So just a coil by itself, what, it's probably gonna go into somebody else's air handler other than ours.
Yeah.
Or you might see some of the big installations where they have so much air they're drawing in, and you just put a coil on the wall and pull the air through the coil, through the boilers or whatever else they might be having in spaces pulling outside air in.
Big power plants pull, just mount the wing coils in the wall and pull the air through.
Yes. So that preheats the air without an air handler directly in front of it or behind it or whatever. Then we have the makeup air equipment where we use our coils, but we have the air handler with it, so we can provide the air handler, maybe filters, dampers, whatever it might be, along with the heating coil. And again, what that's made to bring in outside air to offset whatever you're exhausting. Unit heaters, now we're getting past the makeup air requirement. They just have a large manufacturing or warehouse. And they want to keep it comfortable. So they have unit heaters to heat that space up. That's all we're trying to do. Keep the workers comfortable. And then there's door protection. We don't have to worry about that much here in Texas. Like Doug points out, it's more so every year, it seems like. But you go up in the upper Midwest, when you open the door, there's a lot of cold air that comes in. So we're trying to prevent that, or not prevent it per se, but at least control it. So that's our door protection models we can offer. So we're going to touch upon those too. So on the coils, we offer 3 different types of coils that we get into for LJ Wing. The IFB, and that means integral phase and bypass. And we'll show you some pictures here in a couple slides to see what that does. And that's a horizontal coil, or horizontal tubes in that particular. We have a VIFB, which is the same concept, but those tubes are running vertical now. And lastly, there's the MV. MV stands for multiple vertical tubes. We have multiple headers in that series. And that's again a vertical, like I said before.
Okay.
And so we're going to be deeper in the IFB coils themselves. We're going to give you a little bit of a idea of where they might be used and why. Basically, whenever you're bringing in large quantities of sub-freezing outside air, you want to preheat it. So you're not putting cold air directly into the space or components that might be damaged with that. Some of the applications are schools, universities. Doug can probably mention at least a dozen big campus universities that our coils are just all over the facility. Hospitals, surgery centers you've mentioned, just general rooms in general, laboratories, office buildings and factories all bring in large amounts of outside air for various reasons. And whenever you bring in that outside air in, you want to preheat it the best you can. But you don't want to bring in a bunch of air at -20 if you're up in Minneapolis. So
We're going to kind of crank up the Wayback Machine with this picture. Back in the late 1700s, in the early 1800s, they first started doing some more central kind of systems. And so they had to bring in outside air. They were trying to preheat it. So they used a standard steam coil as a makeup air, and they put a modulating steam valve on it, and then hooked that steam valve up to a thermostat, and they would try to modulate the steam and bring that preheat that air. And you had to know what the entering air temperature was, what you were trying to do leaving air, and you needed to know what the steam temperature was. So there again, if it's 15 PSI, if the steam temperature was 250. So the trouble is that modulating valve, all it can do is open and close and squeeze down the flow of the steam, trying to control temperature. Wasn't a real good way to do it. And this concept eventually froze and broke that coil. Next, they tried a coil, just a same steam coil, and now they added an external facing bypass, and they interlink those so that as the cold air bypass opened, it started closing the steam coil. In order to really make that work, they had to have an air blender trying to blend these two temperatures, the bypass part and the temperature of the air going through the coil. Trouble is, blenders trying to blend cold air and hot air, those two air streams don't want to mix, and the blender has a hard time making them, even though that's what it's designed. It's a very highly engineered plate, you might say, that tries to make those two blend. That didn't really work too well either. But the biggest problem is it takes a minimum of 8 feet to put an air blender in, and the custom air handling unit people that are building these big air handling units are going, we can't live with 8 more feet in the length of the air handling unit. So that didn't work well either. So in the 1960s, L.J. Wing invented and patented coil. And they started out in 1964 with the horizontal version. And then in 1968, they invented the vertical version. And basically we have the dampers built in to the coil and controlled by one control mechanism. And then now we can do, instead of that 8-foot version, we can do from the end of this coil to the next component, whether it's a cooling coil or whatever, we only need 3 feet worth of distance. Air handling unit manufacturers could live with that. And if you put our anti-stratification baffles that force those two air streams to collide at the very end of the coil, you can get away with 2 feet between the coil and the next device. So that was very livable for our customer. Now then, the way this works is at 0 degrees, as cold as, that's their design point, all the air is going through the fin tubes, and the bypass is totally closed. So as outside air warms up a little bit and you get up to 20 degrees, now you're modulating airflow between the fin tubes and the bypass to get the 50 degrees that you're looking for downstream. As you get, say, outside air warms up to 40 degrees, you're almost totally closed off on the fin tubes, getting a little bit of air through there, and most of it's going through the bypass because you've only got to make up for 10 degrees to get to 50 degrees. And then as you get to 50 degrees, the fin tube dampers are totally closed off and you're just strictly bypassing air. Do you want to take the MV?
But, so in the later years, there was a few limitations with that because they were still getting a little temperature override on mild days or whatever. So Wing has come up with the MV coil. Again, that means multiple headers. That's 2 independent circuits for staged heating. So it's 2 headers, top and bottom. You got 2 inlets on top, 2 inlets or returns on the bottom. So in essence, you've got 2 one-row coils in a single casing, just built into one box. So that provides enhanced temperature control that reduced load conditions. So as the temperatures get warmer and warmer, whereas another example we're going to show you here, VAV, where they vary the airflow, not just the temperature, but the actual volume through the coil, that reduced load, they don't need as much heat. So this is able to handle that variation by, at a certain point, you shut off the leading row of fins, shut them down completely, and then your dampers will open and close to maintain the temperature based on one row only. So big benefit there. Minimizes the override, which is a big thing for some of the important labs or hospitals. So what's the benefits of IFB? Maximum freeze protection for both the coil itself and downstream. As Doug's pointed out in those drawings, minimum space requirements. And for the air handlers, manufacturers that are using these coils, that's big for them because it saves box size, it saves roof curb mounting, whatever it might be. Minimum stratification, so you don't have those hot and cold bands going through the area. And we have an accurate, simple control system. Here's the good news about it. That's what Doug was pointing out, that the supply air temperature of 3 feet downstream of the coil will be within plus or minus 5% of the mixed air temperature. Very little variation on those two temperatures, just 3 feet down from the coil. The mixture or the airflows do mix that well, just with the damping range. But if you put the anti-straffle baffles on there, it's even a little bit less than that. So it minimizes the possibility of nuisance freeze that trip because they try to protect components downstream. So, and as we pointed out before in other cases, those never shut down at a good time. They're always going to go about 2 in the morning, 4 in the morning. Maintenance people are not happy. So that will minimize that. So I'll summarize the coils for you. The IFB is horizontal. You see a picture of it there, the finned element going horizontally. So 5/8" tubes for all of these coils we're talking about right now, available in 2, 3, or 4 rows for capability of how much heat you might need. Look at the variation you can offer, 126 sizes, and the airflows from 408 to 62,600 CFM. These boxes here, the finned elements go from 36 inches long to 120 inches long. So can handle a pretty good amount of air, as you can see. Let me back up a little bit to show you this. In this particular case, you're seeing the horizontal with the full face. All the or air would go through the element on this particular case. The bypass is fully closed. This next picture shows a VIFB, and that's just the opposite. We're showing it now with full bypass. The elements are protected. They ship out this way to protect the elements during shipping so you don't get damage on the road. But that's just what they're showing in the picture, is the full bypass and the heating elements all closed up. Again, we're using 5/8" tubes. They handle both hot water and steam in these cases. These are available in 1, 2, or 3 row models. 58 sizes from 714 to 77,000 CFM. To give you a feel how big these can get, the height on various sizes, the biggest one can go up almost 12 feet high. And these bundles you see here, the heating elements, up to 12 of those across there. That's how big they can get. And as Doug has pointed out various times, they've got jobs where they have to have those mounted side by side, up to at least 3 in some cases and larger. So that's how big some of these places are going into that these coils are working with. The MV multi-header unit, I know you can't read it in the picture, but if you could up here, It shows a steam inlet, and steam inlet on the top, steam outlet, and steam outlet on the bottom again. Two independent coils, two independent circuits. It's just two one-row coils with individual headers, what it is. We have 55 sizes available on this. I can handle from 1,078 to, again, the 77,000 CFM. So that kind of summarizes the coils that are made that are typically going to go in somebody else's air system.
How many we sold this?
I can't answer that one. DMV,
Approximately 5, 20, 100
Of the VIFB or the IFB?
MV.
The
MV,
MV.
Oh, MB.
multiple.
Approximately.
Over since we came out with them, probably 50, 75 orders, maybe more than that. Counted them.
Because I just only remember this, it was a big deal when it was first one.
Getting people to, it cost a little more and it costs a little more to pipe up.
and the controls.
Yeah, and the control, it takes a lot more controls.
How big the size is?
Up to.
Well, up to about,
The
12
same
foot
thing
high
the same thing the
and-
other one?
Same as the VIFB size.
well, yes, it's,
Basically.
yeah, it is the same box
Yeah,
size.
because you said that the other one.
That's right. So once we get past the coils that sell by themselves and go on somebody else's air handler, we're gonna get into makeup air units. So again, as we've talked about in other sessions, makeup air is needed to replenish the air being exhausted from the building, whatever reason it might be, or welding fans out there and that of them, paint booth, whoever, might be a lot of different things in the other manufacturing area. But you want to heat that air so you're not bringing in cold, untempered air. That's just going to be uncomfortable for anybody to be around if you're bringing in untempered air, especially up north. I mean, we're a little more lenient here, but up north, it's bad. So we have the wing FAS and SAS units that we offer to maintain effective temperature control by using the same base and bypass design coils. So the steam or hot water, we still have the face and bypass, so the coils don't freeze. That's our big thing. And we're able to control the temperature coming into the space. So we have the FAS, fresh air supply unit, integral face and bypass. Next, we're going to touch upon the HSFAS, high static unit. And we'll kind of touch upon why that was brought out. And then we've got the study air unit. So for some larger CFMs and larger E capacities, we can offer the SAS study air. What that is, here's your fresh air supply unit. This particular picture shows a horizontal model. And these, the coils we just talked about were 5/8 inch tubes. We're now using 3/8 inch tubes for these hot water steam. They're smaller boxes, smaller coils, and the 3/8 inch gives us the heat capacity that we need.
One of the things about this, or designs of this particular makeup air unit is one of the target areas that we go after is boiler rooms where there's one or more, sometimes 6 boilers in a particular room. And so therefore it's got dual actuators built into it. That's the motor that opens and closes the dampers on it. And when this unit shuts off, we close those dampers on the entering air side and the leaving air side so that there's no air blowing through into that boiler room because there's smaller piping in there that can freeze pretty quickly.
So it will isolate that cold air, keep it outside of that open.
Yep.
These are propeller driven, so you just got a axial fan on the back end with driven by a DEFC motor. We've talked about before, the axial fans are good because you can move air with less horsepower, but the limit is they can't handle much static. Explain that in a little bit more too. And it's typically designed to be mounted right at or near the wall, so it's going to pull the outside air in, fresh air drawn in through options of weatherproof hoods or wall louvers. And then it's just discharged right into the space, like you said, a boiler room. You're just gonna discharge it right there for the boilers to then suck in that air for their combustion. And in this model, we offer with horizontal and vertical blades. And you see the picture there. They got the horizontal blades front, back, vertical blades, so you can adjust up and down or sideways to kind of direct the air where you might need it. Now, that FAS, using the same heat section, using the same, we can also turn it vertical and offer it in this arrangement. Same heat exchanger, as I said, 3 feet, salt water, steam, propeller fan, like we talked about before. And this was designed for mounting up near the ceiling to save floor space, and the fresh air is drawn in through the roof, through a roof mounted intake hood. So it's going to be up in the air instead of at the wall level. And then it's going to blow the air back down toward the floor level at that point. This one's available with either fixed or revolving discharge options. And that's the difference. Another key wing thing here. Wing has got so many unique features they offer that bring this one up to revolving discharge is something that the advantage of that is you look at that picture and it's got 2 chutes going out. Well, if that's a fixed discharge, it's blowing air that direction, it's blowing air that direction. If you're working in that corner over there, the air's not blowing on you. It might, start swirling around and eventually it's going to get to you in those back corners. But my example on that is, it's like being late for dinner. You're going to get the leftovers. It'll get to you eventually, but you won't feel the full draft as it hits you. So we offer that as a revolving discharge. See this gear motor over there? That drives this discharge round and round in a slow rotation. So it's constantly spinning around and just blowing air on a complete circle around that space. That's the revolving discharge. So it can either be fixed or revolving. We offer that in various.
And by revolving that discharge, it blows the air further down and wider the plume, the air coming out. It'll increase the square footage that it'll cover. And that's what that charges.
And yes, this is going to give you an idea. I know you can't read this. I want to just point out that the catalog data that we have on this, if you're able to open it up, you'll read. It shows all the discharge options, and it shows MH and mounting height, how high you can mount it. And then the CF is the coverage area. So that's how much area it will cover for you. You see the CR revolving, CF is a fixed, because they will change. You see a revolving that goes from 43 to 40 by 43, but if it's fixed, it's only 22 by 43. So that's the difference coverage you're going to get with revolving versus fixed. But the tech guys, you can read those so you can see what those numbers are, but all of them, whether it's this model we're looking at here or unit heaters, they show a chart like that to help the reps and customers place that in the right area and know what they can do with it.
So when you said it's only a wing option, is it the revolving one that's only? The revolving
Yes.
only?
LJ Wing's the only people that make that.
Okay.
So then all these boiler rooms that Doug is mounting these in, he had reps coming to him more and more that said, they have them boiler rooms further inside the building now. I can't get the air there with the prop unit. It's just not handling the static. So engineering came up with a high static FAS. Now this one's horizontal only, using the same heating section. We didn't touch that part. We left it alone. It's working fine. 3/8 tubes for hot water or steam. But now we're using electronically communicated EC motor with a direct drive plenum fan to handle less fire pressure. That motor is an electronic motor, very high efficiency. You can program it to do various things. You can set it for a constant CFM. For example, if your filters start loading up and blocking part of your airflow, it'll compensate for that to some extent and keep it constant volume all the time. And it can also handle the higher statics that they're concerned about. They can move the air further into the space.
The first one of these we ever built was for a makeup area for a kitchen that was in the middle of a building. And we also put a cooling coil on the end of it. So that they could heat and cool the kitchen area to make up for all the exhaust they have in a kitchen.
Like the FAS, these are primarily designed to be right at the wall opening where it's drawn into the hood or louver, and we blow it or duct it into the area they might need. But that handles higher statics that they were finding more and more. And same discharge blades available on this that we saw in the horizontal IF or FAS, vertical, horizontal, or both. Now, start getting into some of the larger units. Call these our study air model. And if you've been around the plant at all, you might recognize this unit by the picture. That's the same air handler we use on the indoor direct fired unit. This is the same air handler we're using on the outdoor direct fired unit. On the indoor model, all the controls are just external for easy maintenance. And the coil would just bolt to the back of that section there. For the outdoor model, direct fired unit we mounted in this back assembly, we're mounting a coil back there, so the direct fired burner. So the same box, just a different heating medium in the same box. These are horizontal only. Now these, as compared to the FAS, use the IFB coils to get back to your 5/8" tube for better heating capacity. Hot water, steam again. Forward current centrifugal fan, so it can handle higher static pressure and larger airflows. We have, you can see from the picture, smaller units are a single blower, larger models might have twin blowers there. And indoor suspended or outdoor curb mounted installations that we've had for those. For the discharges, we have a simple just discharge looper box, or you can put a box there and direct the air in 3 different directions. Or we have the wing fixed revolving discharge that can be added to those air handlers for the wing features on that as well. So, in summary, the FAS is going to give you 15 different sizes available. They go from 855 to 26,000 CFM. You saw that we offer that in both horizontal and vertical mode. And they have both rotating and fixed discharges available. High static model for 10 sizes available there. They go from 855 to 10,000 CFM, but up to 2.5 inches of static pressure. It's a big difference. So how much air they can move in it further into the building. Those are horizontal only, and then the same discharge options you saw in the FAS. The IFB, or the SAS, I'm sorry, uses the IFB coil again. Indoor and outdoor models available. 19 sizes, airflows from 1,000 to 40,000. So it gets up there pretty good sized units. And again, all of these are horizontal only, SAS. Jump into unit heaters next, and there's some questions on makeup air. Anybody have any questions? All right, we'll move on. Like I said before, now we're past the need for makeup air requirements. I just want to keep the space warm. We're worried about. So we have 5 different models we'll talk about here. We have the HU, is the horizontal unit heater. We have HCF, which is a vertical airflow unit with a fixed discharge option. An HCR is a vertical airflow unit with a revolving discharge. Want to point out that we'd like to keep things real simple here. You know, the old rule, keep it simple. F means fixed discharge, R means revolving. Simple as that. HMS, that's the height mounting unit we're going to talk about. That's vertical airflow, and those are revolving discharge options only on that one. We're going to touch up on our HLC, which is the high level circulator. So let's look at those now. We can kind of see what they are. Bless you. Here's our HU series. And it's just, as you can see in this picture on the right-hand side, it's a simple unit made for vertical airflow, fan the back, blowing across the coil, and putting air into the space. And I want to point out the picture of this coil up on top, how that's just a straight, what I'll call slab coil now, compared to what Doug was explaining with the space in between them for the bypass. You no longer need that bypass. So it's just a straight heating coil now. Very simple. Again, we're using 3/8-inch tubes for this, hot water or steam capability. Propeller fans with TEFC motors. Discharge vanes available, either horizontal, vertical, or horizontal and vertical, like you saw in the FAS. Now, these two things right here, I want to point out the heating section and the fan section for the HU we just talked about, the HCF and the HCR are all the same. Just different arrangements now. The heating section and the air mover are the same across the board. Here's your HCF, vertical airflows. See this picture here? That little motor there, you can't see that, close your eyes. Because this is HCF, that means fixed airflow, so they don't have that motor driving it. As I pointed out, same heating element, same fan section. Now we have 4 different fixed discharge options on the HCF. HCR, you see that motor, same heating section, same fan section, but now this offers 4 different revolving discharge. So, just that when they get a model number, engineering, whatever, instantly know it's going to be a fixed or revolving discharge. I know what they're going to be doing with this part. Now here's our HMS series, vertical airflow. As I said, this is high mounting. This is designed primarily for aircraft hangars.
Originally, blimp hangars. These have been around for a long time.
And they're up in the air up to 90 feet. And of course, years ago, they had a problem job out in Minneapolis when they sent Darrell to go look at it. Darrell's afraid of heights. I get up there and look at this, you know, I'm looking down on top of the tail of a 747 jumbo jet. I got through it. Obviously, I made it, but that was the wrong place for me to be.
These are roof mounted.
No, they're hung from the steel.
Oh, really?
Yeah.
Inside.
Under
Pretty dangerous.
Sorry.
mountain, under.
Yeah, in airplane
On their
hangars.
truss.
Yep. Yep.
But, and catwalks to get up to them.
And a lot of stairs. Now these use 5/8-inch coils, but we don't make these. These are going to be coil we buy out. So these aren't the IFB coils we've been talking about. This is going to be a purchased one. So they're going to put 5/8-inch coils in there for either hot water or steam. Coils are going to mount like here and here, and that blower is going to draw air from both sides and down into that discharge chute. Use a BI centrifugal blower, so it gets a lot of airflow, high velocity, static pressure, and it's a belt drive fan. So it's easy, that belt driven motor on the side there to get to. Once you're up on that catwalk, it's easy to get to it and adjust it. We have 2 different revolving options that are made to work with that high mounting and still get air down to the floor level. So that's your HMS series.
The design of that allow that nozzle and that unit actually makes the air swirl underneath an airplane, which is where most of the service work is done on a plane. So it covers a huge area.
Yeah, I mean, because of the movement you're creating, you're getting it where the workers are. That's an excellent point. You need a category. See, this really a little bit misleading because there's no heater here. This is just a circulator. Listen to our air turnover units. We talked about by moving the air, we eliminate stratification. Well, that's what we're doing here in essence is we're putting this up at the ceiling level, recirculating warm air at the ceiling, and putting it back down to the space where you can use it. Because once that hot air is up at the ceiling, it's of no benefit to you or the workers. It's just going to go up through the roof and you've lost it. If you can blow that back down to the floor level, they're going to be comfortable and you're going to have a chance to reuse that heat and take advantage of it before it's just spitting it out through the building through your roof insulation or whatever. So it puts it back down to the floor level. Same propeller fan, just we have the heater out of it. And we have 4 different fixed or 4 different revolving discharges you can put on this one to get whatever coverage you might need. And again, the tech guy will have the mounting heights and the coverage these can offer you. And just some of the things that all of these could probably handle for you. A mixing box, dampers and or filters, inlet hood, roof curbs, those are all options we can provide to meet ventilation requirements. So on the HU, we have 19 sizes we can offer. Airflows from 750 to 27,000 CFM. And you've got optional horizontal, vertical, or horizontal and vertical discharge blades. HCF, F meaning fixed discharge, 18 sizes, 885, 27,000 CFM, and 4 different fixed discharge options that we can offer you. The HCR for revolving, 18 sizes there as well, same CFM, same high and low end because of, again, same fan section. 4 different revolving discharges here. The HMS, the one for high mounting, 4 sizes with airflows from 24,000 to 30,800. Designed for the high mounting applications, and we have 2 different revolving discharge options that we can put on that. And then the HLC high level circulator. 14 sizes with 2,000, 27,000, and 4 different fixed or revolving discharges would go either way on those, whatever they might need for their application. So that's unit heaters. Next, we're going to talk about door protection. And again, what we're saying on that is upper Midwest especially, it gets cold up there. If that big door opens in the shop, a lot of air comes in. So a door heater, what's that doing is it's trying to blow a blast of hot air at that door. Not to stop it. You can't stop that air from coming in. We want to offset it, heat it up a little bit. We don't have sub-freezing temperatures coming in where the workers are. So that's what we're doing, is putting a blast of air right there at the door.
Is that the same one when you go in a grocery store, they got the,
No,
What do you
we're
open?
going to talk about
that's trying to get rid
That's
of the
next.
bug.
That's next. Here's the other approach. You're just reading our mind.
Oh, sorry.
The wing air curtain, that's what that one is. It's an air curtain. It puts out a high velocity air from the top down to the floor. That creates a barrier. Keeps dust,
And bugs away.
bugs, and it will stop the air from penetrating that
That's
because you're having that high volume curtain or a barrier. That's the 2 things you get into for door.
that barrier will bend with the wind, but it'll stop the wind.
You don't have to in south.
Oh, yeah.
Yeah, we got one out here on the dock.
Really?
Not like we're showing here, but we have one.
Yeah, we have.
One of the older models,
Yeah.
yes. So here's your door heater, DH series. Vertical airflows, and you see they have a high velocity. You're gonna point at the door. You're trying to put much hot air as you can at that point. So you're not gonna be just freezing to death with that air coming in. What you're trying to do. It's the same tubes and that we use for the other. So the heat exchanger is the same. Same prop fan. And this is available with either high velocity jet, like we see there, or varied jet. And we're gonna touch on that one next, what that is. Another one of Wing's little creations I think is quite unique. This varied jet discharge allows a door heater to function as a combination door and space heater. So when the door is not open, you're not worried about that. You can use it for a space heater. And what that is, when the door is open through the door switch, it's going to drive a damper to position 1. That's going to drive the air through a narrower chute and have a high velocity at the door again. If you're trying to stop as much of that, not stop it, but need the best to stop it or overheat. But when that door closes, that switch opens up, the damper goes back to position 2 to a different position for a normal velocity, provide either room or perimeter heating. So you're using that as a combination heater now. You can stop at the cold coming in the door, but you can also use it for space heating. And then when that thermostat is satisfied, the unit shuts down. Your air curtain that you asked about. Now this is a big industrial version. This isn't like you see over a drive-through window or whatever.
Right.
You walk under one of ours, it will give you a bad hairdo.
But those ones that, you know, like a McDonald's drive-through, whatever, they keep insects out of that building. That's the main concern for them.
Yeah,
right.
Hot and cold air to some extent, but they have to keep the insects out. So this is what this is doing, just a larger scale. We have multiple fans with a belt-driven motor across there. And it's designed with a special discharge plenum to provide high velocity air over the entire length. That's why these fans are so close together. We don't want any dead space of air between the fans. That's the entire length. We have that coverage there.
It is a switch the door, right? When the
Yes.
door opens up. No.
right.
Exactly. And we can offer these with just a no heat, like you see there, just blowing the curtain of air down, or we have options for hot water, steam, or indirect gas-fired heat on there. If you need to heat that air a little bit.
And I've got one right now, just came in this morning that they want electric heat on.
Wow.
It actually does. In the next couple weeks, we're gonna take those off of our available.
So our summary for door protection units, the door heater, we're just trying to put the heat there at the door. 10 sizes we can offer you, 4,300 and 27,000 CFM. And you can have more than these in one door. You might have a size range for the unit. We offer the high velocity or varijet discharge options. And then on the air curtain, 10 sizes we cover from a 4-foot wide door to a 16-foot wide door. Now on that 16-foot, I think 14 and 16 feet, we have 2 motors on that one instead of just the one big one. But it is one continuous air curtain all the way across.
And if you get on a door that's even bigger than that, like an airplane hangar door that slides to the side, you just start stacking these air curtains go end to end and cover that whole span.
There you go. So up to 16 foot per single unit. And then again, you hit the heat option there. No heat, hot water, steam, electric, or electric. So
2 more months max.
that vote came up.
Yeah. He is listening.
All right, now we've been talking hydronics all along, but once in a while, even Doug sells gas parts. So there's a couple models here we want to talk about. What Doug shows for gas. And the first is the GA, gas unit heater assembly. And next is the HMG. It's gonna be like your HMS, only different. So the GA is gonna look like this. You got a air handler up there, vertical airflow. And we're using multiple furnaces that we get from our sister company, Sterling, duct furnaces that mount on there to provide the heat. 2 or 4 furnaces in there. Propeller fan, it's a direct drive motor, so we're not worried about having to get up there in the rafters and adjust belts or change belts to the direct drive assembly. And these are available with either a 4 fixed, 4 revolving, or again, the Varijet. So we can take a gas unit and also like a combination door space heater outlet by using this Varijet design on this model. Again, makes it quite versatile what you can get into. And then the HMG, see the same looking picture up there. Same vertical airflow, but now we're using aircraft owners, already know that. 4 indirect fired gas furnaces to provide the heat. And so get rid of the steamer hot water coil, put duct furnaces there instead.
These are the ones that you lower to the ground, right?
No, this is up there on a high level again.
It's always,
These are really big units.
okay.
But this goes up there to, 90 feet or so that you can put them up there.
They have a catwalk going up to
That's
these.
it.
Yeah.
Which represent HMS, it's not the HMG.
No, this, well, there's the HMS, but this is the HMG, the gas fired version of
No,
it.
it's 2 volts. It's all right.
Twin blow, yeah.
Yes, right here. Right there. Twin blowers on the HMG. You're right.
Right.
It's on it. And we have the same, 2 different revolving discharge options on that one. So I think that wraps it up, doesn't it?
I think so.
I mean, the summary here. So the GA series are 6 sizes. They go from 6,000, 22,500 CFM. The indirect fired gas heat options go from 400,000 to 1,600,000 input on those heaters. And fixed, revolving, or Varijet discharges are available. The HMG has airflows from 23,700 up to just shy of 30,000. And we have the 2 different revolving discharge on that one. Again, those for the high mounting applications. Yeah.
Yeah. There's only one.
Flip the coin.
We're allowing the remote to be used